Hello everyone, this is Caplitero. Welcome back to a new episode. We're gonna talk about 3D rendering and how you can initialize a 3D map, but on a plane. We're talking about the plane map using triangles because triangles, as I told in the last video, are the most used. And uh, I'm not going into objects right now. I'm trying to create the map and show you how you can integrate triangles. Now, let's start with a new Sfml project. So we go here, Sfml, and let's call this 3D map. Okay, as you know, in the last video, we've already talked about this. So we can just go here, copy all of this. I think this is the triangle, yeah. Go here, this, go here, create a new item, header. What is it called? Triangle class. Here we're gonna have triangle class. Oh, uh, problem. Oh, misspelled. Okay. Now we should have the triangle from the last time rotating on his axis. Now we can just delete this and we're gonna delete this too because we're gonna create a new function, a new class. I mean, let's call this 3D render map. I have my triangle class right here, and we're gonna go. It's not a lot to write, but I have my notes in case of anything. So let's make this public. Triangles. We're gonna have a pointer with all the triangles we're gonna use. Triangles. Vertices. So you can keep track of how many triangles we have. Int cap, gonna say the size of the triangle just for now. Int size x in case we need it, and size y in case we need it. Gonna create a constructor, implement a constructor or render map. Render map, and we're gonna add int size x, int size y. This doesn't mean the triangles we're gonna have. This means the cube, the squares. So let's show you like we usually do. We're gonna have a map, let's say 2 by 2. Oh, and every time we're gonna divide those in triangles. It's gonna look like this. So how we do that? Well, I'm gonna initialize size x, size x times 2 because we have two triangles per square, and size y, it's size y, but we have vertices, which is size x times size y. Now the triangles are triangle of vertices. Now something interesting. So we're gonna have four. Just copy this. It's a lot of code. So we're gonna go through all the so every square we have a two triangles. We have two triangles. So index means the square, but we're gonna select the first one to be index 1 and the second will be index 2. So we'll have two triangles. This is index I times size x because we have I means one square, one line, one group, and we're gonna have two x's, two triangles depending on I. So here we have 4. So the next one will be so 0, 1, 0, 1, 2, 3. This will go 4, 5, 6, 7. And because iteration starts from 0, so this is index. So we're gonna have 0 times j because we move two triangles at a time. So two triangles, then we add those two triangles. And the corners just mean the corners. 0, I noted 0, 1, 2, and the other one 0, 1, 2. 0, 1, 2, 0, 1, 2. So we've implemented our triangles. Now float we're gonna have to add because triangles are rotating on their origin or center. These triangles will rotate on this point, on this point. This triangle will rotate on this point, but those triangles together will rotate on this point. All eight triangles will rotate on the center. So you can say that the center of them all is the center of rotation for every triangle. So how we're gonna do this? We're gonna take the distance between the first and the last point. The first point for x and y divided by 2 is gonna give always the center. So let's call this distance x so you can visualize it. We're gonna have triangles of vertices -2. We're gonna take the last corners of 1x minus triangles of 0 corners 0. This is the starting point. Actually, it could be -1, but we're taking so -2 is gonna give this one. Corner of 1 is gonna be, actually I think this is 2, but we'll see about that. Triangles corner dot x. No, this is x, so this doesn't matter. divided by 2. And let's say float distance y equals this, but here we're gonna have 2, and here we're gonna have y. So this y and this y. And now we're gonna set 0 pi vertices. So for every triangle, we're gonna update it. So we're gonna initialize it with his initial sizes, but we're gonna change the triangle. And why? This will set the center. This will will change it, and now we have to find is translation. Isn't it? Rotate center, transform. Oh, I forgot to say that this will be transformed in find translation, so we can update our translations. And here we can go find translation. Okay, so you can go here, find translation, and we're set. Anything else I need to add? I'll have 2 functions, rotate and move by. Is the problem? Did I forget to add anything? Oh, I forgot to. Oop. Okay. So rotate will take the X, Y, Z values and rotate the triangle. You already know this. It's just going through all the triangles we've made and move them. The functions are already here. We don't have to think about that. Now, what are we gonna do? Oh, not this. This. We have to initialize. Well, here I'm gonna have to delete this. Vertex array. Let me just boop. Okay. So map. Wait. We go. I'm gonna have to cap under map. I'm gonna have to make this a pointer because we don't have a standard constructor. A cap structure. I changed the name of this. And here we're not gonna do this. in the update, we're gonna have not even this. I'm gonna take this. So we're gonna rotate the map every frame, go through all the vertices, all the triangles, um, draw get the pointer for the uh, triangle in the array. So you're gonna select the triangle and set the position of the triangle in the vertex array to the points of our triangles. Anything else? I don't see any problem. What we do here is we just want to visualize it, so every corner we have a specific color. We're gonna resize the vertex array corresponding to the number of triangles. Every triangle has 3 corners. Set the primitive to triangles and have a 5x5 grid with it will construct it will represent 50 triangles because we have 2 times x times x or y. Let's see. Expected here a let's check. And you can see that the map is rotating. We can actually make it rotate on the, let's say I want to rotate it on the Z value. And you can see that the map is perfectly rotating. And for more visualization, I can say rotate this by, let's make a smaller value. And let's say that I wanted at these positions to have a higher altitude. So when we are rotating it, you can see we have corners at the 0, 0 position. Why do we have black corners here? Is because there's no connection between this point and so we'll have to give a connection for this point, and also wait, gives me this point and that point. That point would be this one. I hope so. But it gives a weird looking because the the altitude of this is higher from the others, but you can see everything is in 3D, quite good looking, and you can do whatever you want with this map. You can color it and add dimension to every point. You can make a even larger map. Let's say that I wanted a 20 by 20 and I wanted to make this a 5. Oh, let's make it 10. And let's delete this. Make it 100, but I think 100 is too much. Yeah, we can actually go here by 0, 0, and make this 25. You can see the map rotating with no problem at all. And if we really wanted, we can actually go here and say map move by, let's say I want to move by 1 pixel, should move to the right. Yes. Can I move it to the back? I don't know. I can't do that because I don't have a perspective. This is just translated to the screen. Yeah, it's not moving. We're gonna have a perspective too in the future, but for now, I think this is enough, and I hope you guys like this. I really like this. I'm working on some kind of map, and it will look nice. But for now, it's not a lot of code. You can see the only thing that I added, it's like 60 lines of code. I mean, 3D is not so hard, but after all, this is the basic. Those are the bases, because in 3D engines like Unity and Unreal and anything else, yeah, there's a lot of code, and I'm not comparing mine to those, but I really like what I did. And if you next video will be quite interesting. But until then, I hope you guys have a nice day. Maybe leave a like, subscribe, and see you next time.